Assalamu alaikum. We know galvanometer is a device used for the measurement of intensity of current in a circuit. It is also used to check the direction of current in a given circuit. In this video, we will discuss the conversion of galvanometer into an ammeter. For that, the galvanometer, which is shown by this symbol, is connected in parallel to a low resistance. Here, the low resistance is represented by letter S. Whenever two components are connected in this manner, we call the combination as parallel combination. If we connect the two components or two devices side by side, such that left terminals are connected together, also right terminals are connected together, then we call such combination as a parallel combination. So when we connect a galvanometer in parallel combination with a low resistance, then we get an ammeter. The galvanometer gets converted to an ammeter. After that, the scale of the galvanometer is calibrated in ampere. Okay, these are the changes we make to convert a galvanometer into an ammeter. Now, after making these changes, the device that we have obtained is nothing but an ammeter. Right? And here, suppose current I flows through this circuit. Then when it reaches point, when the current I reaches point A, the junction A, in this junction, it gets split into two components as Ig. And Ig flows through the galvanometer. Then the remaining current. What is the remaining current? If you subtract Ig from I, you obtain I minus Ig. This is the current flowing through the shunt resistance S. Okay. It flows through the path A, C, D, then reaches point E. Okay. Through the shunt resistance S. Here, the resistance offered by this resistor is 2 ohm, such that the ammeter that we have obtained can provide low resistance to the flow of current. Then the current that is used here also provides a certain resistance to the flow of current, which is represented as Rg. As the galvanometer is connected in parallel to the shunt resistance, we can say that the voltage across galvanometer and the shunt resistance will be equal to each other. Okay, why is it so? Just remember this. In a parallel circuit, voltage remains same. Okay, so the voltage across the galvanometer will be equal to the voltage across the shunt resistance, that is Vs. And how to get the value of V? Voltage can be easily obtained from Ohm's law. So what does Ohm's law say? Ohm's law says that voltage V is the product of current in the circuit and the resistance offered by the conductor. Fine. Good is so. Then here Vg can be obtained by multiplying current Ig and the resistance offered by the galvanometer to the flow of current. That is Rg. So Vg is equal to Ig multiplied with Rg. Similarly, Vs is obtained by multiplying the current that flows through it. The current flowing through S is nothing but I minus Ig, and the resistance of the shunt resistor is nothing but S taken here. Okay, so from this equation, the value of S can be obtained easily by cross multiplication. Okay, I keep S here as such, and this term is taken to the left hand side. So if I do so, this will become equal to Ig multiplied with Rg divided by I minus Ig. This is the value of S. Okay. Similarly, from this expression, Ig value can be obtained. What I have to do for that? I need to multiply this with each term. So what I'll get? I multiplied with S. Similarly, Ig multiplied with the S. Okay. Then this term is taken to this side. It has got minus term. It will become plus. Ig multiplied with Rg plus Ig multiplied with S equals to I. Yes. Then Ig is taken out as common term. Rg plus S equals to I. Yes. Okay. Then what do you obtain? From here, I can write Ig equals to Is divided by Rg plus S. This is the value of Ig, which is nothing but the current flowing through the galvanometer. Understand? I box this for better visibility. Now, if you look at this equation carefully, you will find that the value of S, which is nothing but the resistance of shunt resistance, and the resistance of the galvanometer, both are constant. Okay, so I can say this term is a constant. It is a constant. Whereas I may vary. The current flowing through the circuit may vary. So it is a variable. So this equation can be written as Ig equals to constant for this term multiplied with I. So when we combine equal to sign with constant, what do we obtain is nothing but proportionality. So here we get this Ig is directly proportional to I. From this we understand that when the value of I increases, when the current in the circuit increases, the current that flows through the galvanometer will also increase. This is what it means. When this reduces, it will also reduce. So I can say I is directly proportional to the current flowing through the circuit. Okay. Then the deflection shown by the galvanometer is found to be directly proportional to the current. Okay, as the current in the galvanometer increases, the deflection will also increase. Okay, so according to this relation, when theta is directly proportional to I, then this can be written as, so here I is directly proportional to I. So the place of I can write Ig. So theta will also be directly proportional to Ig. Just remember this. Okay. When we convert a galvanometer into an ammeter, now we connect the shunt resistance. Here, in order to have full scale deflection, the value of S is selected in such a way that the galvanometer shows the full scale deflection. Remember that. Okay. Let's go ahead. Now I am going to obtain the value of S, and I have also obtained the expression for Ig. Now, the next thing, from here it is clear that the galvanometer provides some resistance to the flow of a current. If it provides some resistance to the flow of current, then definitely the ammeter that we have made using that galvanometer will also provide some resistance to the flow of current. So the current that we measure using that ammeter will have a slight difference compared to the current which is flowing through the circuit. It means that the measurement that we obtain will be lesser than the actual current flowing in the circuit. Okay, so the percentage of error, percentage of error is given as delta I upon I multiplied with 100. Okay, this provides the percentage of error that we obtain in the measurement of current using an ammeter. Okay, suppose we have an ammeter which provides zero resistance to the flow of current, then such ammeter will be called as ideal ammeter. But it is not possible to make one such ideal ammeter. Okay, so in this case here delta stands for change or difference. So this can be done as ideal current. Here the current measured by an ideal ammeter minus the actual current measured by an ordinary ammeter divided by actual current multiplied with 100%. Okay, this is the equation used to measure the percentage of error in the measurement of current using an ammeter. Now I will get the expression for the resistance offered to the flow of current by an ammeter. For that, you need to look at this diagram carefully. Here we have a galvanometer and a shunt resistance completely in parallel. So I draw the diagram here. See, here we have a shunt resistance connected in parallel to a galvanometer. Fine. Here galvanometer offers resistance Rg and this shunt resistance offers resistance S. This can be drawn in this manner. I keep this as such. In the place of G, I take another resistance. This value is taken as Rg. If it is so, the total resistance offered by this circuit, which acts as ammeter, is given as effective resistance. So, when resistors are taken in parallel combination, we get the total resistance or effective resistance in this manner. Reciprocal of effective resistance equal to 1 upon S added with 1 upon R G. Then this can be obtained by taking LCM. Okay, for that we cross multiply. RG will go, that's RG plus S divided by the product of these two. S is multiplied with RG is what we get. Then from this, if you want to get the value of effective resistance, then you will take the reciprocal. So what you will get? The effective resistance will be equal to, because we take the reciprocal. This provides a value of 1 upon effective resistance. Then effective resistance will be equal to the reciprocal of this. What is that? S multiplied with RG divided by RG plus S. This is what we obtain here. A box this. Here, effective resistance, the total resistance actually provides the resistance of the ammeter. So, in the place of effective resistance, I take RA. Here, RA stands for, A stands for ammeter. RA stands for resistance offered by the ammeter. So, RA is equal to this RG divided by RG plus S. This is the expression used to get the resistance of an ammeter. Clear? Before I conclude this video, let me provide some important information about ammeter. Ammeter is a device used for the measurement of current. Okay, and it provides the least resistance to the flow of current. Okay, and it is always connected in series. Remember that. An ideal ammeter is one which provides zero resistance. So it is not possible to make one such ideal ammeter. Third thing, suppose I want to increase the range of the ammeter that I have made. In such case, what I will do, I need to change the value of S. So in such case, the value of S, suppose if I want to increase the range of ammeter n times, then I will select the value of S to be equal to G upon n minus 1. Okay. Using this equation, one can easily select the value of S to change the range of the ammeter n times. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.